So good morning, good afternoon, good evening, everyone, and welcome to another very, very nice episode of Between Two Bits. I'm your host, Jason, and with me, I've got Mr. Nice today. Sometimes Mr. Grumpy. Today's Mr. Nice. Okay? Mr. Richard Hall. Say hello, Richard.
Hi, Jason. We also have Mr. Millennial, Joseph. Say hello, Joseph.
Hello. I hope my white hairs don't show on camera, but I'm Mr. Millennial for now. And the next up is Justin.
Hey, y'all. Good to be here.
Who's not
So
very
today,
awake
guys,
this morning.
Yeah, so what time is it for you again, Justin?
7 a.m.
Oh,
Yeah.
There's no hope of me doing a 7 a.m. recording. No hope at all. You're a good man. You're a good man, Justin.
Are you even grumpier in the morning? Because then we have to do it at 7 a.m.
I can't deal with this. I can't deal with people at all in the morning. No, I can't deal with people.
So, Jonathan, take a note.
7 a.m.
7 a.m. for the next one.
Make it happen.
So today, what we're going to be talking about, cloud and moving to the cloud and what cloud to go to and which cloud is better, or is my cloud better than your cloud? So let's start off with an interesting question. Who's better? Which cloud is better? I mean, that's a very, very big question, is it?
I mean, are we limiting this conversation to hyperscalers? What are we talking about here?
Yeah.
Okay, right. What do we mean when we say hyperscalers?
At the root of that question is truly, I think it's sort of a social definition that means Amazon, Google, AWS, Google, Azure, maybe Alibaba. But I think it's international cloud platform vendors. Maybe I'm wrong.
No, to be honest, I mean, that's when we say hyperscalers, that's exactly what we mean. I mean, it's those four main providers, AWS, Azure. Interesting one. Is it Azure? Azure? I
would have said Azure.
What's the consensus around there? It's like the GIF and GIF kind of conversation, right?
It's never color, right?
When I was at Microsoft was around the time they were rolling Azure, and Ballmer said Azure rhymes with Badger. So that's
rhymes with Badger.
Badger, yeah.
Does not rhyme with Badger. But as long as it's not,
otherwise it would be Azure.
Yeah, Azure.
I'm going to start calling it Azure now.
I think the main point of discussion is going to be, for me, the best cloud provider is the cloud provider with the best support. While I was working with the infrastructure team for 2-3 years, our biggest complaints and our biggest benefits with cloud providers came from support. And from experience, there was a big gap in how providers were providing support to small and medium-sized customers and how they were providing enterprise customers support. Because once we get to the scale of Amazon or Microsoft, I mean, the level of service is good. It's definitely great. The technology is there, but the support provided to teams is vastly different between the different.
Well, it's a big change, though, isn't it? I think maybe I'm overlooking other technologies where this also applies, but when you've got cloud, it's not just big and medium-sized organizations that are using them. It's everybody from startups or even single developers that are thinking about a proof of concept that are wanting to use it, right the way up to your Netflixes. So I think that massively changes the support game. It's interesting to see who is able to cover that very quickly. But I don't know that it's necessarily fair to judge the quality of the cloud on the ramp up of the support, because I think this is still relatively new that organizations or big service providers are having to deal with not just one type of entity, but sort of B2C and B2B.
But then one thing that we need to look at, one thing that we usually talk about when we talk about cloud, we talk about availability, right? And how long it can be up, so that you have the most minimal downtime on any of your services, right? But no hyperscaler can really give you that 100% availability that you would really, really like. And usually you look at support agreements and they say 99.9999%, right?
You're talking about the 99.999% availability promises or SLAs. When has an on-premises system ever reached that? Ever? I think we do have to bear that in mind, that I actually think, and I may be very wrong here, but from what I've seen in my experiences, the cloud now is probably better and more available than any on-premises system I've ever worked with before. Because when an on-premises system were to shut down, it's usually because the server room had lost power or whatever it was. There'll be many reasons for it, and I'm simplifying. But that would take an awful lot of time to rectify. Whereas with cloud downtime, I've never had any really bad experiences with it.
Yeah, and it's much easier to automate coming back online compared to on-prem. That's, I think, the difference. But I wanted to mention also on availability is you're as good as your weakest link. And what's happening in most companies that we've worked for, all of us, is that we use software also hosted on different providers. So you're hosted on AWS using a service hosted on the AWS, could be in a different region or a different data center. And although AWS itself provides you with a certain availability, the service you're also integrating within your software needs to be at that same level. Otherwise, you're as good as your weakest link.
I agree with that. 15 years ago or so, there was a lot of talk about 5 nines. That was a big thing. And I think the world kind of woke up to it. Just because you have a server that will stay up, all but 2 or 3 minutes a year, doesn't mean that your software is that stable. And, for the most part, software just, there are going to be issues with software. And I was working at a telecom company. We had a mission critical system. And this has been a decade ago. So not that long after that. And someone introduced one single line of code that brought the system. We had about 30 developers on a call that started at noon, and they solved the problem. They found the line of code at, 3 a.m. So yeah, it's software. Software has bugs.
And you, I take it, banned from writing any code into prod after that.
It wasn't my code. But yes, I am now officially banned, to answer the question.
A big benefit of having cloud data centers in general is that you can have ones for your QA, ones for your some sort of sandboxing for your different environments, to avoid issues like Dustin was saying when you reach production and have a breaking line of code that will take you offline. You can very much anticipate these beforehand on your own sandboxes before you get there. And it's very easy to provision with all providers. I don't think there's any advantage in that sense between providers. So it's a lot harder to break code, break at least your availability that badly, to dip under 99%, I would say.
So knowing that, and knowing that you have different kinds of systems for different kinds of purposes in your infrastructure, at what point maybe would you consider a multi-cloud? For most larger organizations, is it all having it all in one cloud because you only want to have one agreement and streamline your suppliers, the reason for it? Or would you consider maybe, hey, this multi-cloud thing actually is something which might actually make more sense, especially if, for example, I am a bank where most of my infrastructure is mission critical. What do you guys think?
Yeah. Well, what I think is that cloud providers are really, really good at selling you stuff. They're really, really good at locking you in by saying, you want a gateway? You want to install a load balancer? Do you want to this and that? It's built in. It's 2 clicks away. It's right there. It's available. It's directly integrated. Whereas if you want to do a multi-cloud system and you're needing some sort of API gateway, for example, you got to stay away from all of them and go for a fourth, fifth provider of an independent provider, which, as I said, will have a different SLA, will have different. You're opening yourself up to another different provider with bigger risks. So I think that's, for me, the biggest hold up from going multi-cloud is probably the products that you're missing out on from each provider.
What I was going to say was that there are surely benefits to multi-cloud in the same way that there are benefits to any application, product, whatever, where there are different versions of it. One version will do something better or more efficiently than the other version, which will do something better and more efficiently than that version. And you just want to make the best of everything. You want to take the best bits from each one. Along with that, of course, you've got, when one cloud is having problems and you can just switch over, default over to another. There are all sorts of benefits, I think, to the multi-cloud that we wouldn't be able to probably cover in this podcast or videocast, whatever we're calling this, or in many. I think we do have to consider that, I think anyway, that apart from the extra work, and it will be extra work, having more than one is always going to be a benefit, surely.
Have you had any customers, Jason, Justin, Richard? Have you had any interactions with customers that had multi-cloud? Can you shed some light on how they used it or what they thought the benefit was from that kind of setup?
Actually, that's an interesting one. I had quite a big customer who, for obvious reasons, I'm not going to name, but they actually went for both AWS and Azure for their multi-cloud strategy. And the reason for that is that they had part of their infrastructure already on a Microsoft stack, and they had part of the other infrastructure on a more open source Linux-based stack. And what they decided was that it was much better for the systems integration to integrate their current Microsoft stack on Azure with a product like, for example, Databricks, and at the same time as well on Azure as well. And at the same time, what they did was they had all their infrastructure on AWS for more of their Linux open source kind of products they were using, as well as having Snowflake on AWS as well. And it was, at that point, it really becomes just a choice, just a personal choice of what you prefer more, or what kind of agreements you're getting more out of it as well. But in certain ways, they almost had the same infrastructure, just completely duplicated using different services on the infrastructure. So if one set of services just went down, they would just roll over to the next set of services and back and forth as they needed. Now, this is a very, very large company. And that kind of a strategy, I don't know. This is a personal opinion. It's not really a professional opinion as such, but I can see the benefits of something like that. But there's also quite more complexities when you're looking at multi-cloud, isn't there?
Yeah.
Well, to answer your question, I've seen companies who have multi-cloud in place. Generally, it's been because they are moving from one cloud to another, and it's a long process. It's complex, and so they make a presumption that they're going to be in two clouds for a year or 2 years or however long it takes them to make that move. But I think this underscores what Richard was saying, which is, there are benefits and strengths and weaknesses of all of the different hyperscalers. And when as companies' strategies shift, as their CTO changes, things like that, there may be compelling reasons for them to either move from one cloud to another, or move a line of business or a particular replatform some particular piece of their development or workflow into another cloud vendor. So that's what I've seen.
What about data sovereignty? For me, comes to mind when, for example, we offer private link support both on AWS and Azure, allowing customers basically that are on Azure or on AWS, the data doesn't transition to the public internet. So you can integrate with an external tool and the data just stays technically locally, but it stays on one with one provider without transitioning over the public internet. And we've seen some big interests from a lot of large customers saying this is something that's interesting for us, and all our security guys love it, and this is what they want to do. And it's another example of lock-in, because the moment you open up yourself to a multi-cloud, you're also running the risk of transitioning your information over the public internet, and we've seen problems with that in the past.
Yeah. So when would you go multi-cloud? When your customer demands it.
Another point that you touched on was data sovereignty. So if we look at regulation, is your choice mainly made sometimes because of the location of the data center from the hyperscaler?
Definitely.
Based on where you are geographically?
If you're in mainland Europe, the choice is made for you. There's no other choice. There's no second option. You have to choose one of the data centers that is in mainland Europe, even bar the UK. So you're already limited in what you can do with that. That's for sure. When
Australia as well.
Yep. Yeah. And the United States, if you're working with any sort of federal governments or any sort of governmental bodies, the choice is made for you pretty much. There's a very, very small list of providers that can give you that kind of service. Very, very small. Do you want to touch on like independent players? What's the name of that French provider? Is it OVH?
So actually that's OVHCloud. So funnily enough, I host my own personal services on OVHCloud. And
why do you
machines with them for quite a long time. And
so what made you go for it?
So for me, one of the things that I do is I host websites for small shops around here in Malta, and I do that for free, just to sort of help them out through the pandemic. And it's just something that I've done. So one of the things that I wanted was an infrastructure where I could sort of control fully. And the reason I went for OVH is because what I was looking at the time was I wasn't looking for a very fluid infrastructure. I was looking for a very solid infrastructure in terms of, instead of going actually for VMs and machines that you're just bringing out, what I wanted was a bare metal server hosted in a data center that I know, and at a cost-effective price. And more than anything, it's because I wanted to know what my static costs were going to be able to budget ahead. But then again, my workload is very, very, very small. So I am paying still in the region of 70, 80 euros, a month. And purely it's a very static cost, because I want to keep my own static cost down, because at the end of the day, I'm just doing this sort of like for charity in a sense. That many of the smaller providers allow you to have a fixed cost, because you're hiring out the equipment in their own data centers, and you're self-managing all that equipment yourselves. However, the hyperscalers are pretty much managed providers. So they manage the whole infrastructure, everything for you, and you're just managing your virtual infrastructure and stuff. So the difference here is being able to understand sort of like the static costs which you would get from the smaller providers, but maybe they won't have enough services compared to the larger hyperscalers that you would use. But I still think that even though you have a static cost-based pricing structure for smaller providers, and you have what we call a consumption base. So as much as you're using in your computations or whatever, that's where your main costs come from with your hyperscalers. If you're an enterprise, you're not really going to go with a smaller provider now, are you?
Definitely not. But what do I do? Why don't we do the exercise of saying we can give different scenarios and see what advice we would give for each? For example, let's say you're a migrating customer from on-prem to cloud. What would be your advice when it comes to providers? Not as a choice of provider, but more as an architecture, as a general advice for a customer migrating from on-premise.
The first recommendation, what I would say is, we've been talking about them all here. We talked about the support, we talked about availability, multi-cloud strategies, regulation and sovereignty, the location and the cost. The very first thing what I would look at is location. More than anything, what does your own regulation say of the country that you're based in? because that will limit your choices already. I mean, there's absolutely no, if, for example, you want to go with one of the large hyperscalers, but from the 4 of them, only 2 or 3 of them provide a data center close to your location in your country. That's your choice, really. Those are the ones.
Or does it delay your move to the cloud? So do you think, very much like I love sort of taking it out and doing sort of analogies or similes, but I'm waiting for a new smartwatch. I could have picked up the Apple one, but I'm not an Apple guy, so I'm waiting for the Google Wear option to come out, and I keep waiting and waiting and waiting. Does that cause people to delay moving to the cloud because they've got a particular vendor that they want to go with because of all of the bells and whistles, but they're not in their location? So does that mean
watches
that
are different, though?
I know watches are very different. At the end of the day,
I think it's perfect analogy. For instance, when Azure came out, they actually didn't offer SQL Server, which was, the Microsoft database in the cloud. So it's actually very difficult as a Microsoft stack development shop to move to the cloud because you had to, transform to, I guess it was SQL Azure at the time. So it was, I think it can delay things, but at a SMB, a small, medium-sized business level, I would say the first step to cloud is SaaS. We see many small businesses that the hyperscaler, the cloud platform it's not even a thought in their head because they are simply using all of the SaaS services. They don't own a server. They don't even think about where the servers are. They're just using SaaS. And that's the first step is, spin down your Outlook servers. Let's just get on SaaS products and, get out of that sort of self-management game because that's one of the main benefits. And Jason, I would argue that, you're, saying, I like to have a piece of steel sitting in a room somewhere. You're missing out on the benefits of, hey, I need that to be double the size instantly. And, that's one of the big benefits of cloud. You just don't think about redundancy. You don't think about scaling. It's just done for you.
Mm-hmm.
But what about, so the company that we said, I think we all agree that SMBs will, as you said, use managed services, completely remove all that question of how it's running, as long as it's running smoothly and they're providing a service. That's all that matters. So what happens when they reach a size that will become, like we're starting to discuss multi-cloud or maybe spreading at what is the inflection point in which you say, maybe I should start considering this a bit more than just SaaS?
Data, for one thing. If they start moving around, PII, that kind of thing, then in storing it, then as we already talked about, the choice may be made for them. You need to do this, period, or you are out of compliance and fines and bad things happen.
Bad things happen. That is the bombshell statement.
Well, it's always like what they say, right? If you think compliance is hard, try non-compliance, yeah?
I like that.
That's the reality of the situation there. Let's come up with 5 recommendations in total. 5 recommendations for any enterprise, large organization looking to move to the cloud.
Set a budget before negotiating with any service provider.
The one thing as well, which I'll add with the set a budget, is most hyperscalers actually provide tools to be able to manage your budgets as well.
Mm-hmm.
And warning systems and notifications when your budget has reached a certain amount, mm-hmm. which you can set manually yourself.
Yeah.
But I'd also add on budgets is set a realistic budget as well.
Yeah. You're not running on dimes and pennies.
You want to migrate everything, and it's like, I only want to cost me, like 2% of what it will really actually cost me, because it's not going to happen. So understand your limits and set your budgets. Who wants to go next?
Identify managed services. So the things that you can get out from under without even considering what hyperscaler you're going to go to, and the implications of that as well. So if you are, for instance, moving to a Snowflake database, then you may have to choose where that Snowflake instance is located, what you want to use. So there may be some considerations there, but there are plenty of good reasons just to look at all the stuff that you manage and how you can manage it.
Exactly that. I mean, Snowflake is one of those services which manage most of the instances for you anyway. So it's a very, very good way to start testing a migration to the cloud. Maybe the first step is exactly to sign up and start using, for example, Snowflake services within your hyperscaler of choice as a first step before you start to migrate most of your other infrastructure. That's always a good first step. And migrations are always the first step to any on-premise to cloud kind of projects, really. Richard.
Hey, I'm struggling on this one. I really am. This isn't really I think more about I'm less about architecture than I'm about the details, the nuts and bolts, putting bits and pieces together. So my fundamental thing, if I was going to make this choice, I would push for making sure that the provider that you have, or the providers that you have the right tools, have the tools that you need, and the tools that your development team or whoever's going to be using it want to use. Because it might be the cheapest, most available cloud going, but if it doesn't have the functionality that you need, then you'll have it in the cloud, but it'll still be doing what it did on premises, give or take, if you're not able to actually enhance upon it. So my focus, and I know it's not everybody, but my focus would be on the functionality.
But it would, because that comes down under compatibility. You need to make sure that the infrastructure you're trying to migrate over and the services that you're trying to use are compatible with the hyperscaler of your choice, right?
Mm-hmm. Yeah.
So that's actually quite a good one, though.
It felt like a pretty pathetic one, to be honest, from my point of view. I was like, I'm not an architecture guy, and we're talking about architecture here.
I would add as a fifth one, as a suggestion, would say, although you may stick with one provider, don't put all your eggs in that one basket. Because although they provide services, there are plenty of companies out there that will provide you a lot of very reliable, very good tools that you can use within your service provider. Mm-hmm. And don't lock yourself in too much.
Actually, that's a really good point as well with what I was mentioning about the functionality. Make sure that you're building from the mindset of, we need to be able to easily move this. It might be that you want to move to another provider that's just brought out this new bells and whistles piece of functionality that you really want to move to. And if you've built your system so that it's so tightly coupled to the cloud provider that you're working with, you can't move that for ages. If you've built it so that it's not so tightly coupled, then it's just a case of lifting and shifting a few bits and pieces over. I mean, I'm massively simplifying, but ultimately make it easier for you to move.
So that would be number 4. And my 5th, I would probably add, is check your local regulations. Check the laws in the country that you're in. Have a look at the industry that you are. If you have a supervising authority, like for example, you're working in finance, or you might work in insurance, or any kind of or public, even when you're offering services to the public sector in the country as well. Make sure that you check what it is that you're allowed to use, or what regulations you really should be following, especially when it comes to stuff like PII, so, which is personally identifiable information.
Or get a good legal team.
Yeah,
get good lawyers.
That always helps as well. And always have the lawyers check your legal agreements as well.
Yeah.
So I think that's it. I think those
one.
are a good one. You've got another one.
I just thought about it. Don't have custom availabilities on your contract with different customers. You may be pressured with certain customers to say, we want higher availability, sign this here. Don't sign. to have the same availability rates to all your customers. That's it. That's my last one. Right.
Perfect. So thank you guys. I hope you enjoyed this episode on our views on how you should be looking at clouds and hyperscalers. And now we're going to move on to our next segment, where the very, very talented Mr. Richard Hall has a bit more to say on it.
Thank you. Well, actually, at the moment, at this point in time, I'm in a bit of limbo. We don't actually I haven't built anything as yet. There will be something, but I'm going to be as surprised as you are. So this is our job of the week, and I'll be eagerly tuning in.
This week's job of the week is about collecting data from a source we often find ourselves wanting to get data from, but can be a lot harder than it looks. It may also give Joseph an idea as to how he can crawl web pages searching for MySQL libraries using Talend, for those of you who remember episode 1. In this job, I will be keeping it as simple as possible so that I don't go on for too long. I'll be using Talend to extract link titles and URLs from a website. Here you can see just how simple the job structure is. The first component we have is the HTTP request component. We can see the URI set to a web page, in this case www.bbc.co.uk. The method is set to GET. The next component is a tflow to iterate component. The main purpose of this is to allow the HTML page data to be stored in the global map, with the next component triggered by an iterate link. This will allow the next component, a tjava flex, to be initiated for every row. We can see in the tjava flex that we have the start code, main code and end code populated. We'll look at that again later. Finally, we have the tlog row. This has been configured to vertical mode to display the output vertically. Arguably, the most important feature of this job design is the routine that allows the use of the JSoup library, the HTML scraping tools routine. The first thing we'll look at is how the JSoup library is used here. To link it, we go to Edit Routine Libraries and set the JSoup library. I realised when filming this that the version of the JSoup library had been updated, so I will show how to set it again in a few minutes. But before we do that, let's look at the code in the routine. The HTML scraping tools routine has just one method called findLinks. This takes one parameter, which is the HTML body of the web page being processed. The method returns an array list of hash maps, which hold the link data found. The body string is passed by the JSoup class, and we select all link elements, represented by the A tag. If any links are found, we go to a while loop to inspect each link element found. We retrieve the elements href, text and title attributes. These values are added to a hash map, which will be added to the return val array list. The code to do that can be seen here. We see it added to the return val array list here. Once the loop is complete, the return val is returned here. Let's take another look at the tjava flex to show how this is used in the job. The findLinks method is supplied with the HTML body, which is stored in the global map by the tflow to iterate. You can see that the global map key is row1.response_content. This represents the row and the column. The findLinks method is returned to an ArrayList variable called links, and we create an iterator from that variable. This drives the while loop, which calls the main code section to fire. In the main code section, we first retrieve the next hash map we will look at for every firing. We then retrieve the title and text values to variables. We retrieve the href value to the href output row column. Finally, we check to see if the text value is null. If it is, we set the output row title column to title, otherwise we set it to text. This is to ensure the output row title column is not null. In the encode section, we simply close the while loop. Now I need to make a small change to a previous setting in the job. Previously, I had the job processing the BBC News website. Unfortunately, I discovered while recording this that there was some unfortunate news which wasn't really appropriate to show here, so I am changing it to the science news section of the BBC. Nothing unfortunate can be found here. To do this, I simply remove the old URL and add the new one in the URI field of the THTTP request component. Now to run the job, with no unfortunate content being displayed this time. As we can see, it works. But before we look in more detail, let's look at the JSoup website. Here we go to jsoup.org/download. I originally built this with version 1.14, but when I came to show the JSoup download page, I noticed that it had been updated to 1.15. Why not show how easy it is to change? So I'm downloading version 1.15, and now I'll go to edit routine libraries of the HTML scraping tools routine. I remove the old library, then add the new one by clicking New and selecting the downloaded library in the Install a New Module field. Click OK and finish, then we're done. Finally, let's test to see the job will still run with the new library. As we can see, it does. Now to show the content being retrieved matches the web page. I'll search for a link that I know is there. This one is about NASA. We can see the title and URL here. And if we go to the BBC Science page, we can see the same article with a link here. So this was a relatively simple use of the JSoup library with a Talend job, but hopefully it gives you a few ideas as to how you can potentially go a lot further with it. As always, let me know if you have any questions.